camera, doggone it. So we'll come over here and hope that I'm still aimed. And the video is blurry right now, but it'll be okay. Okay, now, here's the equation now. We want to solve this equation. So we use the rules that we have, and I'm not going to quote the rules this time. Just log of this plus a log of this equals a log of this times this. So this tells me log base 2 of the quantity x plus 2 times 3x minus 5 equals 4. Well, that was easy. Okay? And now it's easy to convert this to exponential form. And 2 to the 4th, of course, is 16. And now, what kind of an equation do we have? Well, it should be clear this is a quadratic equation. So this is a quadratic equation. If this was equal to 0, then we would simply solve it by saying, well, x is negative 2 or x is 5/3. Okay? But we're not going to get a 0 over here. Actually, yeah, you can't get 0 over here. Okay? There's no power of 2 that's equal to 0. So your log can't be 0. So you're always going to have a number over here when this happens, which means you're going to have to expand your quadratic expression on the left and then subtract this so you get it in standard form. I'm going to go through the details because people want to skip them, and I know that's not a problem for you, but other people could be viewing this. Okay, so we distribute x times this plus 2 times this. I want to emphasize this. That F word thing doesn't apply here. It does, but I dislike it so much that I don't use it. And then we distribute through here 3x squared minus 5x plus 6x minus 10 equals 16. And you know that now we're going to combine our terms and we're going to have just a simple quadratic equation. And we're going to be able to test the discriminant to see if we can solve it exactly, see if it's factorable. Now the equation is going to end up being 3x squared plus x minus 26 equals 0. Now the only way we can factor 26 is with 2 and 13, or 26 and 1, and there's no hope that numbers like that are going to give us something that that factors. But just to be sure, the discriminant is b squared minus 4ac, which goes under your radical, which is going to be (9 squared minus 4 times negative 26 times 3). That's going to be 81. Let's see, that's going to be 104, and 3 times 104 is 312, which is 393. 400 is a perfect square, 361 is a perfect square. This isn't a perfect square, so you got to use the quadratic formula. I'm not going to waste time here. With something that should be second nature. Plug these A, B, and C into the quadratic formula, and you'll get your solutions in terms of a square root of 393. And that's 3 times 131. You're not going to factor square out of that. Okay? So it's going to be an ugly looking thing, but you're going to easily get decimal approximations to the solutions, as close as you want them, and that's going to be sufficient for most applications. Okay, so there we have another example of an equation. Now, we did an earlier example where we got a polynomial equation, and that's probably pretty hopeless to solve using exact numbers. This one, we know for sure doesn't give you exact numbers. Okay. The cubic equation we had before, you can use the rational roots theorem to verify that there are no rational solutions. Okay, and now let me take another quick look and see if there's anything that's coming up that I think anybody should have any problem with. Yeah, there is another example that I would not necessarily have thought of. Okay, here's one. We don't have just a number over here, you have a log. And the log could be to any base, and it's not really going to matter what the base is in this case. Not going to make any difference at all. Okay? Okay, so if we combine what we have over here, well, we can write this as log of 2x. We could combine these right away, but let's just write it out this way. Log of 2x plus a log of x minus 4 minus a log of negative 5x equals 0. Then we can write this as the log of 2x times x minus 4 yeah, okay, over negative 5x equals 0. Well, any log, any expression whose log equals 0, that expression has to be 1, because the only power of any base, the 0 power of any base is 1. So this tells us that negative 2x times x minus 4 over 5x equals 1. Now, if your log is base b, you know that we'd have this equal to b to the 0. No matter what b is, b to the 0 is 1. Okay, so let me just make a note here. B to the 0 equals 1 for any base. So now our equation becomes minus 2x times x minus 4, multiplying both sides by 5x. So now negative 2x squared plus 8x equals 5x, but I'm just going to bring the 5x back over here, so that negative 2x squared plus 3x equals 0. It's a quadratic, but it's really easy to factor, and when you can factor in an obvious way, it's a good idea to do that. So we get x times negative 2x plus 3 equals 0, and now we can use the 0 property of multiplication. If you multiply two things, get 0, that means at least one of them has to be 0. So we get x equals 0 or negative 2x plus 3 equals 0. So our solution set is 0, and if we solve this we get x equals 3/2. So this equation that looked like it might turn out kind of nasty turns out to be pretty easy. Okay. You know, if you understand these examples, you're in good shape for the homework that'll be due at the time of our next class. I'm going to go on and talk about some other topics that are coming up, just to give you a little head start. And now it says charge the battery pack. So I had 61 minutes